What is going on, guys? It is time for another episode of our Java OpenGL 2D game development tutorial series. Okay, so today what we're going to be doing is we're going to be making our test player into more of an actual player. In other words, we're going to make it so that we can actually move him around. If you remember in the last video about animations, we made the test player be a flashing Nicolas Cage face kind of thing. Today what we're going to be doing is we're going to be making it so that you can move him around using the input classes we created before. So in the test player class, in the update method, what we're going to do is we're going to say float x input equals 0 and float y input equals 0. And what we're going to do is I'm going to say if first, actually, we're going to have to go to the input class, the key input class, and we're going to make it do some things here. The way I like to handle key input, there's two different ways you can do it. Well, I'm sure there's more than two, but there's two different ways that I do it. One of those is to create individual variables like public, static, boolean, up for the up key, and then in key pressed, we check to see if the key event's key code is the up key, and if it is, set this to true. And then in key released, we check to see if it's the up key, and we set it to false. That's one way to do it. Another way you can do it that is a bit more dynamic is to create arrays, or to create an array of booleans, public, static, boolean array called keys, and set that to be equal to a new Boolean array with a length of, for our purposes, we'll say 256. And then in key pressed, all you have to do is say keys e.get key code, because all these key codes are integers, well, shorts technically. So each key code is going to have a unique one of the booleans in this list. So we can say keys e.get key code is equal to true. And then in key released, we just do the same thing, except set it to false. And then, let's go ahead and make this private static boolean keys. And we'll create a static function, public static boolean get key, and we'll pass it an integer that is a key code. And then we simply say return keys key code. And this is a much more dynamic way of using key input. Instead of using individual variables for each one, we create one list so it can handle new keys that we haven't predefined. Now, you might get out of bounds exception if you're checking for a key code that doesn't, or if you pressed a key on the keyboard that is outside of this range, that has a key code that is higher than this number. You could probably look up and find out what the maximum key code is. So you can set your boolean to that, or your boolean array's length to that. Although one thing we do know is that since the key code is a short, this can't be higher than the maximum value that can be stored in a short, which is 2 to the 16th power. But we won't worry about that for now, because 256 is sufficient for our purposes at the moment. So what we're going to do is in the test player class, we're going to say if key input dot get key, and then here we pass it a key code. Now, when we were setting up key input, remember that I mentioned that it's important that you keep track of whether you're using the aught key codes or the newt key codes. This is where it matters, because in the key input class, we're using the newt key events, because this is a newt key listener. That's why it's extremely important that right here, whenever we say key input dot get key event dot vk left for the left arrow, it just automatically imported key event for me. Notice which one it imported. It imported the aught key event, and this is not good because these do not match the newt key events. The key code for left according to the aught key events is not necessarily the same as the key code for the newt key event. So what we need to do is we need to get rid of this and then tell it to import and choose the newt key event instead. And it's important that you remember this every time you want to use the key input, or else it will mess up. That did happen to me before, and it took me a while to figure out what was going wrong, because it just automatically imported the wrong one for me instead of asking me which one. So, back to creating our test player's input. If key input.getKey key event.vk left, then x input minus minus. If key input dot get key event dot vk right, then x input plus plus. The reason I do it this way with the floats like this is because I want to makes it much easier to have inputs cancel each other out. So if you're pressing left and right at the same time, they should cancel out. So since we subtract one for the left and then add one for the right, they cancel each other out. Same thing for the y. If key input dot get key event dot vk up, then y input, I forget if it's plus plus or minus minus. We'll just stay plus plus for now. If it's different, we'll change it. And finally, if key input dot get key event dot vk down, then y input minus minus. Okay, now we're ready to actually use the input. What we're going to do is, as it is, since we subtract one or add one to each of these, or both, so they cancel each other out, we want to move. That means we're going to be moving at 1 unit every frame, but we want to be moving 1 unit every second. So what we need to do is multiply it by the time delta between updates, which is in our game loop class, but we might have to make a getter so we can access it. So go back to the game loop class. Target time is the one we're talking about, I think. It's this right here. So we're going to have to do something to get the target time. Yeah. Public static float. No, sorry. Yeah, actually, we want to float. Public static float update delta is what we'll call it. What we do, the reason why we want a float instead of a long, since even though this is an integer, I guess not a long, but an integer, which is the number of nanoseconds for every update, what we really want is to get the number of seconds for every update. So to do that, we need to return 1.0f divided by 1, hang on, I might be doing it wrong. Let me think. No, I'm doing it right. 1.0f divided by 1,000,000,000,000 times target time. I think that's right. I hope that's right. It should be, because we want to return basically 1 second's worth, which is this, divided by that, 1 second's worth of nanoseconds. I sure hope I'm doing that right. I think I am. I have kind of a headache right now, so my maths might be a little off. But let me see. Test player. We're going to say x plus equals x input times game loop dot update delta. Y plus equals y input times game loop dot update delta. Now, like I said, if we just did x plus equals x input, we'd move 1 unit every frame. But if we do x plus equals x input, we would times game loop dot update delta, then we move 1 unit every second. So if we run this and we try out our movement, it's looking good. I'm able to control it. I'm moving up, down, left, no, right, left. So I can do all of this. I can do up, down, left, right, etc. So that's pretty cool. And we still got a little animation on it. So that's neat. In fact, if we wanted to, I could say that, actually, let's save that for another episode. So if we wanted to make it so that we can move at different speeds, we could add a speed variable like run speed. Right here, I'm going to say, each of these values is going to be multiplied by run speed, like that. Then we can create a variable up here, public float run speed equals 2, indicating that we want to run at 2 units per second. So we should run twice as fast as we were running before. And we do. Check that out. So that's pretty cool. All right, that's all the time I've got at the moment. If you like this video, please don't forget to like. If you've got any questions, leave a comment below, and I'll do my best to answer it. If you've got any feedback of any kind, just leave a comment. Don't forget to subscribe. I try to upload videos every Monday through Friday, unless there's a holiday or something like that. And yeah, thank you very much for watching. I really appreciate it, and I will see you in the next video.